All right, we're going to talk about the unit circle, which is sort of the foundation of everything we're going to be talking about this semester. So the unit circle has a center at 0, 0, and it has radius 1. Okay, so in a unit circle, the length of the intercepted arc is equal to the radian measure of the central angle. And you can think about that because S equals R times theta, right? And if R is 1, then the arc length equals the measure in radians of this angle. Okay, so let xy be the end point on the unit circle of an arc of length S. The xy coordinate can be described as a function of the angle. So this is what we're going to do a lot, is we're going to think about an angle here, and here's the terminal side, and we're going to ask where the terminal side intersects the unit circle. Okay, so it's at this point xy. All right. So really, the unit circle is just a circle with radius 1. There's nothing really fancy or mysterious about it. It's just a circle with radius 1. And we're going to think about this point here, the xy values of this point where it intersects, where the terminal side of an angle intersects that unit circle. Okay, and you can see we've got some things labeled here, sine t and cosine t, that we're going to talk about more in the next slide. But let's just think about that. So we have a right triangle here, right? If this point is xy, we have a right triangle, and the hypotenuse has length 1 because it's unit circle, and the circle has radius 1. And we've got a side here and a side here, and we're just going to call those sides particular things. We're going to call this side here sine, and we're going to call this side here cosine. Okay? You might remember from previous classes the term SOHCAHTOA, right? SOHCAHTOA. So you could think about that. If this is our angle, T, so opposite over hypotenuse is just 1, right? So our opposite side is sine of t, right? And if you think of CAH, so CAH, our adjacent side is this here over hypotenuse, which is side length 1, right? So we're going to call this length sine of t and this length cosine of t. Let's think about that a little bit more here. So an important thing to realize is that these are functions of this angle. If you give me an angle, right, I can put that on the unit circle and figure out what sine of t and of cosine of t are. So sometimes we use parentheses around this t, this input value. Sometimes we don't. But this x value is cosine of t. And this y value is sine of t. Okay, x is cosine of t, y is sine of t. So maybe we have this example here. So we have this point P on the unit circle corresponding to an angle T, and they tell us that the x value of this point here where it intersects the unit circle is 1/2, and the y value is square root of 3 over 2. Well, what is cosine of t? Cosine of t is 1/2, and sine of t is square root of 3 over 2. Okay, we can just read it right off. We don't have to do any fancy math. This is cosine of t, 1/2. This is sine of t, which is square root of 3 over 2. What about in this case? What if our t is 90 degrees? Well, let's think, okay, where does this terminal side intersect the unit circle? Well, right here, and that point is, the x value is 0 and the y value is 1, right? This is a circle, it has radius 1. This is going to be 0, 1. This is our cosine value. This is our sine value. Cosine of 90 degrees is 0, the x value, and sine of 90 degrees is 1. Okay, we could just think about that. We could probably, for any of the quadrantal angles, you could probably figure out what the x and y values would be and then know what the cosine and sine values were, right? All right, so we can put this together into an identity. Again, we're going to use this all semester long called the Pythagorean identity, which might remind you of the Pythagorean theorem, which is where it comes from. So before we think about sines and cosines, let's just look at this right triangle here, We've got a right triangle. One side length is x, one side length is y. The hypotenuse is 1. What do we know? We know x squared plus y squared equals 1 squared, or 1, right? That's the Pythagorean theorem. Well, this x value is cosine of t. That's how we're defining it. And this y value is sine of t. So cosine squared of t plus sine squared of t also equals 1. This is the Pythagorean identity. We're going to use it a lot. You can see where it comes from. Right? It comes from the Pythagorean theorem. And let's just look at this notation here. See how we have cosine squared t? That's another way of saying cosine of t, the whole thing squared. We usually write it like this because if the 2 is out here, it could be confusing, like, did we just mean the t was squared, or did we mean the whole thing was squared, right? So this is just a different way of writing cosine of t squared, okay? Or sine of t squared. All right, so how could we use this? Here's an example. They tell us that sine of t is 3/7 and that t is in the second quadrant. So remember, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So we just draw some angle over here. We don't know what it looks like. There's the terminal side. And they tell us that sine of t is 3/7. Okay, sine of t, remember, is the y value. And we wonder what this x value is. Well, how could we figure that out? We could use the the Pythagorean theorem, right? We could say cosine squared of t plus sine squared of t equals 1. We don't know what cosine is, but we do know sine of t. It's 3/7. So we square that, we get 9/49. Subtract that using fractions. Cosine of squared of t is this thing. So cosine of t could be, when we take the square root, remember we have to say plus or minus square root of 40/49. The denominator is just 7. We can simplify the numerator to be 2 times square root of 10. So cosine of t is plus or minus this thing, 2 square root of 10 over 7. Which one is it? Well, you tell me, is the x value of this point positive or negative? It's going to be negative, right? Because the x value is over here. Right? If it was positive, it'd be somewhere over here. This is negative. So we're going to choose the negative 2 times square root of 10 over 7. And that's something else that we'll think about a lot more as we go along. How do we choose positive or negative, depending on which quadrant we're in? Okay, so that's the first time we're thinking about this.